like -90 degrees. That
Okay,
would be like
so
20 just counterclockwise.
a 90 degrees counterclockwise rotation. Okay, what's another prediction? Someone else.
I think it's a 180.
Okay, so a 180. Okay. Anyone else have something different?
360.
How do you know it's not 360? 360, you cannot guess 360. Because the 360 always ends up in the same place, so there would only be one image.
270.
Okay, 270. Now we're just guessing everything. Okay, anyone else? Anything different? Think back, we've learned about different types of transformations, not just rotation, but there's all the other ones.
A reflection?
Reflection, okay. What type of reflection? Or even if you don't know the type.
Wait, what's the one with the teleportation? I forgot what it's called.
Transformation?
Translation?
Translation. Do you think it's a translation?
Yeah, I think it's a translation and a reflection at the same time.
Miss, I think it's a reflection.
Okay, so maybe it's a reflection instead of a rotation.
Wait. Oh god.
Okay. Well, we have some possibilities. Now we're going to actually figure it out. So we're going to, let me go to a blank slide. We're going to start by getting the coordinate points for A, B, C, and then A prime, B prime, C prime. All right. A, B, C. Somebody give me all the coordinates for A, for B, and for C.
A.
Eric,
Sorry.
go ahead.
B, oh, I do C.
Jalen, you can do C. Eric, you can do A. Perla, you can do B.
A is 4 and -2. Common negatives.
Okay, other way around though. -2, comma 4. X, comma Y. Okay, Perla, B.
1, 3.
1, comma 3, good. And Jalen, what's C?
C, wait, the other way around, right?
X, comma Y.
Oh, okay. All right. -1 comma. No, it's -3 comma 1.
-3, comma -1. There you go. All right, good. Now, for A prime, B prime, and C prime, I want to hear the people I haven't heard yet. So Janelle, Samaj, Emily, maybe Daniel.
A prime is 4, comma -2.
Good. 4, comma -2. What's B prime? Emily, Janelle, or Emily, go ahead.
3, 1.
3, comma 1, yes. And Samaj?
-1, comma -3.
Good. Perfect. All right. So now I look at what I have and figure out what was the pattern. How did I go from A to A prime, B to B prime, C to C prime?
Lopez, you forgot the -2.
Thanks. Thank you. Okay. How did I go from A to A prime, B to B prime, C to C prime? Tell me in words.
Can you say the question?
How did I go from A to A prime, B to B prime, C to C prime? Daniel, I see you looking at your phone. You're not looking at me. Let's go. You're the only one who hasn't answered yet, so maybe you can do it for us. How did I go from A to A prime, B to B prime, and C to C prime? What was the pattern?
Path.
What was the pattern?
All the X and the X and the Y are switching around, but they're not changing their signs.
Perfect. So the X and the Y just flip, but the signs don't change at all. So you just go from X comma Y to Y comma X. So now this is where, if you've memorized your rules, this should be really, really easy, because once you have those rules memorized, you'll know exactly what this is. If you don't have it memorized, you're going to have to go back in your notebook and check which of these does it match up to? What type of transformation? Who can get it first?
Can I say it?
Go for it,
What I
Charlize.
think it is?
Mm-hmm.
It's a reflection across the Y equals X.
You got it. You got it. So literally just from memorizing this, you guys can get it. Like when I first asked you guys, you weren't sure. There were a lot of possibilities. It might have been a rotation, might have been a reflection. Nobody here knew anything for sure. But now, once I write down all my points, there's no question about it. This is a reflection across Y equals X. And as a reminder, Y equals X is this line right here. The one that is the diagonal line, the positive diagonal line. Now let's check to make sure. Does this look, in fact, like it's a reflection? You can tilt your head, tilt your screen, so you can look and check. B and B prime, do they look about the same distance from the red line? Okay, silence, awesome. How about A to A prime? Does that look about the same distance from the red line?
Yeah.
And then C to C prime, same thing. We're gonna check to make sure that we did get the right answer. And in fact, that is a reflection across Y equals X. I'm seeing lots of blank screens, no cameras on. I don't know where y'all are at, but that's not okay. That's not okay, not in this honors class. Y'all want to turn your camera off? Go to intensive math, because that's not the game we're playing here. And Ms. Lopez is starting to get more and more angry every day with this class. Okay, thank you, Perla. All right, let's go to the next. So today, let me go back. Today's topic of the day, we're already done. We've learned all the 3 transformations we need to know: reflections, rotations, and translations. So today we're going to look at the concept of symmetry, and then also we're going to look at series of transformations. So basically, series of transformations is when you put everything together. So you're going to see different questions today where they do a translation and a rotation and a reflection, and maybe even all 3 in one. So it's going to be very important, especially now, to have those rules memorized, because if y'all don't have them memorized, there's no way, like there really is no way you're going to know what you're doing. So we have to be very, very good about that. Couple definitions. Do not write everything yet. Okay. So a figure has symmetry. The definition for symmetry is a figure has symmetry if a rigid motion exists that maps the figure onto itself. So what does that mean? There's a couple of different keywords here. Rigid motion is all the things we've been talking about. So translation, rotation, reflection. And basically, if you have a shape or a figure on a graph and you can do something to it that'll bring it exactly right back where it came from, that means that there's a line of symmetry. So a line of symmetry is a line, is a line of reflection. So symmetry is when you can, there's actually, I'll go into this, but there's two types of symmetry. One type of symmetry is reflectional symmetry, which they kind of say it over here. So reflection of symmetry is when there's a line that can cut it in half. And then there's rotational symmetry. And rotational symmetry is when you can turn the shape and get it back, get something that looks the same as where you started. And we use the angle of rotational symmetry. Only highlight this. The angle of rotational symmetry is the smallest angle of rotation that maps a figure onto itself. So there's kind of a lot to highlight, and we're kind of cutting these definitions apart, but I'm going to explain what all of this means in just a minute. So the most important thing is that there's two types of symmetry. There's reflection of symmetry, reflectional symmetry, and then there's rotational symmetry. So as you guys are writing down these two, or well, technically 4 definitions, I want to pay attention to the two images to the right. So the little moon shape has a line where you can cut it in half and you have the same thing on both sides. So for my moon, the line of symmetry is the one that cuts it in half this way. And you kind of always want to think about the line of symmetry. You want to think about it like if you have a piece of paper. If that moon was a piece of paper and you folded it in half on that line, the two sides would match up perfectly. Okay, so it's kind of like, I kind of think about it like a butterfly. A butterfly, when it flaps its wings upwards and it's in half, it matches up perfectly. So that's what my line of symmetry does. And then for my star figure, you can think about it like if you have, you know those, when you go to like a state fair, or sometimes they have them like at the beach and you have those little windmill things that spin around? Or you can think kind of like a fan, if you have a fan in your room, right? You want to think if I turn this, I'd like turn it around its center. So for this star, if I turn it around this much, I'm going to get a star that looks exactly the same as where it started. So that's why a star is going to have rotational symmetry, because you can rotate it just a little bit and you're going to line up exactly where you started. So reflectional symmetry versus rotational symmetry, 2 different things, but sometimes a shape can have both. So let's look at the moon. We know the moon has reflectional symmetry because there's a halfway line, but does the moon have rotational symmetry? Can you rotate it and get to the same place?
No.
No, right? The moon, if you rotate it a little bit, it's never gonna line up again until you go a full 360. So if you can only do it if you have by doing a full 360, that doesn't count. So for my moon is never gonna line up with itself until you go all the way around. However, with the star, does the star have, we know it has rotational symmetry, but does the star have reflectional symmetry? Can you cut that star in half?
Yes.
Okay, Janelle's, where do you see, like, where can I cut this star in half?
In the middle.
In the middle. So up and down or left to right?
Up and down.
Up and down. So if I draw a line right down the middle, up and down, if I were to fold that star in half along that line, my left side and my right side would line up together. So the star also has reflectional symmetry. It has both. So different shapes are going to have different types of symmetries. So what I'm going to do now is we're going to do something a little bit different. All right, take a look at all these logos. Each of these logos might have rotational symmetry, reflectional symmetry, both, or it might not have any type of symmetry. So I want you guys to take 2 minutes and just look at each logo and try to decide which type of symmetry it has. Maybe it has both, maybe it has none, but have an answer in your head because I'm going to call on every single person. Two minutes.
Miss, so you said that reflectional symmetry is when you can like fold it in half, right?
Mm-hmm.
And then rotational, okay, got it.
Thirty seconds. Here's the order that it's going to go in. I'm just going straight down my roster the way it is on the screen. So for Mickey Mouse, this is 1. We'll do this way. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of you here, so we're going to do 8. And then we'll do the last 2 together. And the order is going to go like this. Number 1 is Emily, 2 is Alejandro, 3 is Daniel, 4 is Eric, 5 is Jalen, 6 is Janelle's, 7 is Perla, 8 is Samaj. So be ready. Emily, I'll give you like a couple seconds just to think again. All right, whenever you're ready, Emily, what type of symmetry does Mickey Mouse have?
I think it has reflectional symmetry.
Good, reflectional symmetry. And I'm gonna go ahead and draw the line of symmetry that cuts Mickey Mouse in half. If you turn Mickey Mouse, he's not gonna line up with himself unless you went all the way around. So he does not have rotational symmetry. Nice job, Emily. All right, Alejandro, number 2. Alejandro, are you there?
That man gone.
All right, I'll make him go at the end. Number 3, Daniel. We can't hear you.
Both.
Very good, both. So does anyone know what this logo is by any chance?
Volkswagen.
I think it's a gas station or car
Yeah,
dealership.
Wait, is it BMW or Volkswagen?
We're doing number 3.
Oh, that's the gas station.
Yeah, BP.
Yeah, I was right.
All right, so yeah, it has both. You can cut it in half, and you can cut it in half a million different ways. I could go this way, I could go that way, I could go that way. It could go really, it has like a bunch of different lines of symmetry. And if you turn it, it can line up with itself over and over again. So this one definitely has both. All right, Eric, number 4.
Reflectional.
Reflectional, very good. You can cut that guy in half. Jalen, number 5.
Neither.
Very good.
That's a Twitter logo.
That's Twitter. Can't do anything with him. Janelle's number 6.
Both.
That's right. We got. Actually, hold up. This was kind of a tricky one. So if I cut this one in half, it might look like it matches up, but there's something that's not going to match up. Can anyone point that out?
It's not reflect. It's just what's the one with for
The
reflect?
bottom.
Right.
If they reflect.
Right. It's not going to reflect because this part right here, this arrow, if it were symmetrical, there would have to be the arrow over here. You guys see that? So when you kind of look at it right away, it looked like I actually made the same mistake. I thought it was going to be symmetrical, but then I was like, wait a minute. Nope, because that little part, that arrow would have to line up on the other side. So this is not actually symmetrical, but it is definitely rotational. All right, number 7, Perla. Darth Vader. Say that again?
Reflectional.
Reflectional, for sure. We can cut him in half.
I want to go to Walmart.
And Samaj for Walmart.
Both.
Both.
Actually, no. I want to go to Starbucks.
Malware.
All right, Walmart has both because you can definitely cut it in half a few different ways. And you can also turn it. Alejandro, you missed your turn. You were number 2. So for number 2, do I have reflectional symmetry, rotational symmetry, both or neither? You have 3 seconds, my man.
If he doesn't know what that is, that's disappointing.
We can't hear you.
Oh yeah. Okay. So what I was saying is that it depends if you consider the shadow an actual shadow, but so far it's reflectional.
Reflectional.
What type of logo is it though?
Huh?
Yeah, who knows what that logo
Volkswagen.
is?
Hey,
Volkswagen.
who said it?
Samaj.
Why? I was trying to see if he could figure out his own self.
Well, too bad. All right, number 9, shout it out. What kind do we have? Rotational, reflectional? Both, neither.
I think neither, because if you want the colors to be in the same spot.
Okay, so the colors throw you off. What if it was just black and white? What if they were all the same color?
Yeah, then.
It would have been reflection. I mean, it would be both.
Would it be both?
No, only.
If it was black and white.
Well, if it was black and white, but even if I cut this in half, hold up. This, yeah, does not line up, right?
No.
Because that would not match with itself. So it would only be rotational. And then Starbucks, shout it out.
Reflectional.
Reflectional, yeah. All right. So that's all the types of symmetry. So I think with that, you guys are pretty good at figuring out which one it is. There's just one more thing you have to know, which is for rotational symmetry, each of the what we call regular shapes or regular polygons, the reason we call them regular, they're only regular if all the sides are the same length. So a square, all 4 sides are the same length, so that's going to be regular. A triangle has to be an equilateral triangle, or in other words, each of the sides has to be the same length in order to be regular. So whenever you have a regular polygon, all the sides are the same length, you can figure out the angle that will get them, when you rotate them, to line up again. So for a triangle, for example, I know that this triangle has to go about that much. It has to go a certain amount of degrees in order to line up with itself. And the way that you figure out the amount of degrees is you are going to take 360 and divide it by the number of sides that that shape has. So a triangle has 3 sides. So 360 divided by 3, what is my angle of symmetrical rotation?
120.
120. The angle of rotation for the triangle, for a regular triangle, would be 120 degrees. What about a quadrilateral, a square?
90.
90 degrees, precisely. Pentagon, 360 divided by 5.
I'm gonna use the calculator for this one.
Use your calculators. Let's go, everybody, right now. Figuring it out.
72.
Say that again.
72.
72 degrees, good. Keep it going. Hexagon,
60.
60. Heptagon,
That has 7 sides, right? 51.428571.
Let's just
just
round it
figure
up for now. 51.4. Octagon,
45.
good. Nonagon,
It's called a nonagon.
9 sides, nonagon.
I honestly didn't know that. Is nobody gonna say the number?
I've never heard of that.
Yeah.
Well, now you have. Let's go. 360 divided by 9.
40.
40? Is that what you said?
Yeah.
Good. And finally, decagon.
36.
36, yeah. All right, so notice that as you add sides, so the more sides its shape has, what happens to the angle of symmetrical rotation?
It decreases.
It decreases, exactly. So triangle has to go all this way just to line up with itself. A square only has to go 90 degrees. Pentagon, it keeps getting smaller and smaller and smaller, 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 and smaller. But you will definitely see a question like this on a test, I guarantee, because they love to ask this question. But if you just remember, 360 divided by the number of sides, boom, that's all you need to know. Any questions on this? All right. Now, let's do a couple. So this is literally from a test. This was from a test. So this is what it would look like when they ask you a question about symmetry. This is what the question is going to look like. So can I have a volunteer read the question, both the top and the bottom part? Daniel, get off your phone. Come, sit close. Who's going to read? Go ahead, Eric.
A regular pentagon is centered about the origin and has a vertex at 0,4, which transformation maps the pentagon to itself.
Perfect. So this is your key words. You want to know which one will map the pentagon to itself. So what that means, Can somebody kind of like say that in normal words? What is it trying to ask?
Is it the rotation?
So it's basically asking, what can you do to this pentagon that will result in a pentagon that's in the same exact place? So what can you do to this pentagon to make it go right back to where it was? Or to make it line up once more?
A reflection across the x-axis.
Okay, so hold on, let me write this down. How do you make it line up with itself? Okay, so one option would be a reflection across the x-axis. So let's look at the x-axis really quick. Let me highlight it. There's my x-axis. If I were to take my pentagon and reflect it, it would go this way, over the line. If you folded it in half in that direction, would it line up with itself? So I see Perla saying no. Do we agree?
C.
Okay, right. The thing is, if you reflected it over the x-axis, you would end up with a pentagon that looks something more like this, right? So that would not line up at all. So now that's the wrong answer. So it's not going to go over the x-axis. Let's look at our other options. What do you guys think?
I think it might be C.
All right, so how about let's go through them together. Okay, a reflection across line M. Here's line M. If I fold it along this line, will it line up with itself? No, okay. Now let's look at the rotation. So there's two options. It could either go 100 degrees or 144 degrees. And what do we know about we just did this. What's the angle for reflection for a pentagon, a regular pentagon?
Oh, so it would be D.
72 degrees, right?
Yeah.
So if I turn it once, if I go one time, 72 degrees, I line up, right? But I could do it again. If I do it one more time, 72 degrees, it would line up again. So how many total degrees would that be if I did it twice?
144.
144, exactly. So that's why answer choice D would be the right choice, because you can rotate it more than once, but it has to be a multiple of 72. Okay, otherwise it's not going to line up. Now, I know Eric mentioned it in the chat, right? A reflection over the x-axis will not make it line up, but if one of the answer choices had been a reflection over the y-axis, so if we were looking at this line of symmetry, would that line up? Yes or no? If we reflected it over the y-axis, would it line up? If you fold it in half. Give me something, guys. I see Perla's the only one who ever does anything. Okay, thank you. Yes, it would. So if that had been an option, that would have also been correct. But in this case, we had answer choice D. Here's another one. Like I said, a lot of times you're going to get questions that don't have a picture attached. So you have to be able to read and understand it just by reading. I mean, sometimes you can draw a little picture on the side of your notebook, but if you don't have a picture in front of you, a lot of times you kind of have to visualize it. So I want to know what type of transformation will carry a square onto itself. So same thing. If I have a square, what can I do to that square to get it to line up to itself? So I want everyone to read through the answer choices carefully. And we'll talk about what each of them means. So I'll go through each one, but I want you guys to just read them to yourselves first. Okay, so starting with A, a reflection over one of the square's sides. So what that's saying is if I have a square, I drew one, so you could also draw this down on your piece of paper, but if I have a square and I draw and I make this side of it the reflection line, so if you reflect it over its side, where will it end up? Will it be on itself or somewhere else?
Somewhere else.
Somewhere else, right? So if I reflect this over the line, it would end up on the other side of the line. So does A carry the square onto itself? Good, no. Okay, B, a reflection over one of the square's diagonals. So a diagonal line goes not from one side to the other side, but from corner to corner. So since I have 4 corners, I could draw a line in this direction. If I reflect now, the square is not that perfect, so maybe let me draw it a little bit better. Hold on. I don't know if you can draw shapes with this, but let me see. Maybe not. Nope. Okay. Well, I'm going to try my best to draw a little bit of a better square, but that's a little bit better. Okay. So if I make my diagonal line the reflection line, and I fold it over that line, will it line up?
I think it will.
You think it will? Does anyone else agree?
I do. I agree.
Okay, a few thumbs up. Good. So would this type of transformation carry it to itself? The answer is yes. All right, next one. A rotation of 90 degrees clockwise about the square's center. That should be an automatic, you know the answer. If I go 90 degrees around the center, will it line up with itself?
No.
No?
Wait, isn't it yes,
Hmm?
Isn't it yes?
You think it's yes. Okay, Eric thinks it's no, you think it's yes. Why?
Because if you take the square, it's equal. So no matter how you turn it which way, it's gonna look the exact same.
Okay. What's the angle of rotation for a square?
Oh, I'm dumb. Oh wait, it is 90.
Right.
90.
360 divided by 90. Sorry, by 4 gives you 90. So if I go 90 degrees this way, I'm going to line up with myself. So yes, 90 degrees, definitely yes. What about 180 degrees?
I think yes too. Because
You
it's
think-
like the last one we did.
Right. So if I go 90 degrees I get to this one. If I go 90 degrees again, I'm going to end up there. I'm still lining up with myself. Since 180 is a factor of, or a multiple of 90, any multiple of 90 will get you to the same place. So I could go 90 degrees, 180 degrees, 270 degrees, 360 degrees, and I would still end up with a square on my page. So yes. Last one. 180 degrees clockwise about one of the square's vertices. So this one adds another layer because now it's saying it's going to rotate not around the center, but it's going to rotate around the vertex. So that means that my center of reflection or rotation is that black dot. And if I went around 180 around that black dot, am I going to end up in the same exact place where I started?
No.
Definitely not. I would end up somewhere else. I would end up down here. So you have to be careful and you have to read carefully because this is definitely not going to be correct. The only thing they changed is the point of rotation. From answer choice D to answer choice E, they only changed one thing. And that was a very important thing to make sure you read carefully. Any questions on this problem? All right, so symmetry for sure will come up. You have to make sure you read carefully. You have to make sure you know your angles of rotation. And if there's a picture, visualize as much as you can. If there's no picture, draw one. Like this, you guys have to get into the habit of drawing your own picture if it doesn't have one for you. Because if you can visualize it, you're more likely to get it right than if you just do it in your head. All right, one last one, I think. Yeah, one last one. So I want you guys to read this one carefully. We're going to vote on the answer. Can I have a volunteer read the problem out loud?
Can I read it? I don't
Me.
know.
Oh, Tyrone.
Never mind.
Tyrone hasn't been able to participate yet, so go ahead, Tyrone.
The figure shows two perpendicular lines, S and R, intersecting at the point P. In the interior of a trapezoid, line R is parallel to the bases and bisects of both legs of the trapezoid. Line S bisects both bases of the trapezoid.
Okay,
Which
pause there.
transformation-
Pause there. Pause there. They just gave you a bunch of words. Do any of them matter?
No.
Do I care what bisects what? Do I care if it's perpendicular? No, I have a picture in front of me. I can see it with my own eyes. I don't need all that.
It's up our
So
brain.
when you're reading all these types of problems, it's going to try to trick you by giving you a bunch of words that are honestly unnecessary. So like Tyrone, as he was reading, and as you're reading, if you are like, none of this makes sense, that's okay. You got a picture in front of you. Use that picture. Okay? So don't worry if you don't understand what it's saying, because that's not going to matter in the end. What matters in the end is the actual question that it's asking. So Tyrone, finish it out. What's the actual question?
Which transformation will always carry the figure onto itself?
Perfect. Now you guys take a look at all of your options. Take 1 minute to decide on an answer, and we'll vote. All right, that's all the time you got. but that should be enough time to visualize what you need to know. So let's vote on it in the participants button. Click on participants. Click on participants and get ready to vote with your check mark when I call out the answer. So give me a check mark if you chose answer choice A. All right, give me a check mark if you chose answer choice B. 2, 4, 5. 5 check marks and a thumbs up. Okay. Give me a check mark if you chose answer choice, hold up, C. And give me a check mark if you chose answer choice D. Okay, very good. The answer is B, reflection across line S. That's the only one that's going to get you to line up with, get it to line up with itself. If you fold it along that line, fold it in half, both sides will line up. In all of the other options, it's not going to line up perfectly. Any questions on rotational or reflectional symmetry? All right. So that's all for symmetry. Now we're doing one other type of problem, which is what I said before, sequences of transformations. For all of the stuff we just did with symmetry, you didn't really have to write a lot of stuff down. But for these problems, we are going to be writing. So only write down what I write down. You do not need to copy down the problem. You do not need to copy down the graph. Just copy down what Ms. Lopez writes. Sound good? All right. Number 1. Can I have a volunteer read number 1?
Paula, you can read now if you want.
Okay. Given parallelogram ABCD as shown below, translate ABCD, x comma y becomes x plus 2 comma y minus 6, and then rotate ABCD 90 degrees counterclockwise about the origin.
Perfect. So we're going to do 2 transformations. The first one is a translation. The second one is a rotation. So we're going to write down the first one. We're going to write down just what they showed us, right? They said x comma y becomes x plus 2 comma y minus 6. Before I write all of my points down, what does this mean about the transformation? What is happening on the graph? Use your directional words. Left, right, up, down. What's happening?
It's going to go 2 units to the right and then 6 units down.
Perfect. 2 units to the right, 6 units down. So all I'm doing is, for each of my points, I'm going to go ahead and start with my original points. So I know that these graphs don't have numbers on them, but each unit is just 1. So I'm going to do this real quick because we barely have enough time. I want to make sure I get through it. So A, 1, 2, 3, 4, 5, -5, comma 3. B is -1, comma 3. C is -2, comma 1. And D is -1, 2, 3, 4, 5, 6, comma 1. So I start with my originals. I'm going to perform the transformation just exactly as I see it. I'm going to add 2 to my x and subtract 6 from my y. So, and let me use a different color for this so everything is nice and neat. Let me make this one green. All right. So A prime, -5 plus 2 is -3. And 3 minus 6 is -3. So I know that A prime will be -3, comma -3. So I'm going to put that down. Now I go for B prime. Same thing, I'm going to add 2 units to the x value and then subtract 6 units from the y value. So -1 plus 2 is 1. And 3 minus 6 is negative 3. There's my B prime. Now I go on to C. Same thing. Negative 2 plus 2 is 0. And 1 minus 6 is negative 5. So there's my C prime. And then finally, negative 6 plus 2 is negative 4. 1 minus 6 is negative 5. So there's my D prime. Let me draw my trapezoid, or parallelogram, I mean. All right. So that is transformation number 1. Any questions on transformation number 1? Going once, going twice. All right. I'm just going to make this a little bit smaller so I can fit the rest. Now I'm going to write down transformation number 2. Transformation number 2, based on my problem, is a 90-degree counterclockwise about the origin, right? So what are my rules? You should already know them because we memorized them. What is my rule for this, for a counterclockwise 90 degrees? This was from yesterday.
Positive y, comma, negative x.
Good, nice job.
Yay!
Good job. See, you already started, you know. You got to have them ready by tomorrow, you guys. I'm not even, like, when I tell you I am not joking, and I don't like to be serious, but I'm being serious right now. Memorize. Memorize, memorize, memorize. Okay. So that was transformation number 2. So now I'm going to take what I had over here, all of my green points become my new original points, right? So I'm just copying these down. Matter of fact, I'm not even going to bother copying them all down because that's a lot of work. And Ms. Lopez ain't got the time. So I'm just going to draw one long arrow. So now I'm transforming the green points.
Well, actually, we're all the way past chapter 7 now. We're actually into the 2020s now. But don't worry, I want to give you...
Daniel's clearly just watching TV. Great. It's going to show when you take your test. Okay. Notice my blue. Actually, let me make it a different color because our first color was blue. So let me make it red. All right. Now I already had A prime. So this is now A double prime, B double prime, C double prime, and D double prime. And just like our rule tells us, we're going to flip the X and the Y, and we're going to turn that X into its opposite. So if I started out with -3, -3, I'm going to switch them around. I have -3, but then my original X value becomes +3. And I'm going to do that all the way down. So now again, they switch. So I have -3, but then my +1 becomes -1. For C prime, they switch. So I have -5. 0 will just stay as 0. And then for D, same thing. They switch. So I have -5, but then -4 becomes +4. So here are my final coordinates for my final image. Let me go ahead and plot them. So A double prime is, and actually before I plot them, which quadrant, if I'm doing a 90 degrees counterclockwise, which quadrant will this new image be in? That's 1, that's 2, that's 3, that's 4. Where will my image be?
4.
Quadrant 4, yeah. All right, let's go ahead and do it. -3, comma 3. Wait, which way does the clock go? Clock goes this way. Yeah, okay. Miss Lopez sometimes confuses this anyways, by the way. Uh-oh, Perla. We might have done this the wrong way. Let me see.
What do you mean?
Uh-oh. Hold up. I think we might have gone the wrong way.
Yeah. Oh, that was a turn, right? Yeah.
Mm-hmm.
Wait.
Did we go the right way or the wrong way? What happened?
What? No, we went the wrong way. Wait. Yeah, we went the wrong way, miss.
We went the wrong way. We went this way. That's clockwise, and it was supposed to be counterclockwise. Uh-oh. Did I just do a bunch of work for no reason?
But is it
Yes,
counterclockwise?
you did.
Oh, it's -y. I'm so dumb. Oh.
So we did the wrong rule. Okay. You know what? Let's pretend we didn't make a mistake, and this wasn't a 90-degree. What was it?
It was 270. No.
270. Yeah.
Or it was just a -90.
Or -90. You're right. But either way, we ended up over in quadrant 2. So I'm sorry. That was honestly my mistake that I didn't catch the original mistake. But
we were so happy that I memorized it.
I was like, good job. But here we are. Okay. Well, you know what? It's Thursday. Thursdays are rough. But either way, this is what you're going to do anytime you have a double transformation or a sequence of transformations. Writing down the coordinate points will get you where you want to go, especially because on a test, you guys are not going to have the ability to graph. It's on a computer, and for the most part, you're not going to be able to graph. So you really have to base everything on the coordinate points and make sure that the coordinate points line up to the answers on your page. Let's pretend, you know what? Scratch everything. Let's just try one more time. Let's do something different. But we're going to follow the same exact process. So I'm going to do my first transformation. Which, what do they say? Read it carefully. It says, reflect the figure across the y-axis and then translate according to the rule, right? So I start by listing all of my points. Well, I'll start by giving the rule, actually. So what's the rule for a reflection across the y-axis? Look back if you need to, but remember, we have to have these memorized.
A reflection across the y-axis. I remember this. When the x is positive, the y is negative. So it's x, comma.
You have that backwards. So that's a reflection across the x-axis.
Oh,
so
sorry. After x-axis. Okay. When the y is positive, then the x is negative.
There you go. So a reflection across the y-axis gives me -x, positive y. So that's,
if I wouldn't have to remember.
Well, you gotta have it memorized. All right, so G, H, I, and J. Okay, G is 2, -3. H is 1, 2, 3, 4, comma negative 1. I is 5, 6, 7, comma negative 1. And J is 7, comma negative 1, 2, 3, 4. Okay. Let's go ahead and reflect. When all I'm going to do is turn my x negative and keep the y the same. So G prime is negative 2, negative 3. H prime is negative 4, negative 1. I prime is negative 7, negative 1. And J prime is negative 7, negative 4. Thank you, Alejandro. Okay, let me go ahead and graph that image. Negative 2, negative 3. Negative 4, negative 1. Negative 7, negative 1. And negative 7, negative 4. Okay. All right, there's my image. And that was my reflection across the y-axis. Okay, so now that I've reflected across the y-axis, I can do my second transformation. For this one, they give it to me. I'm going from x comma y to x plus 7 comma y plus 4. So I take what I have in red, I'm going to add 7 to the x and add 4 to the y. Just going right through this. I'm not even, I recognize that it's 140, so we're really behind, so I'm just going to breeze right through. So negative 2 plus 7 is 5. Negative 3 plus 4 is 1. Negative 4 plus 7 is 3. Negative 1 plus 4 is 3. Oops. I prime. Negative 7 plus 7 is 0. Negative 1 plus 4 is 3. And then J double prime, negative 7 plus 7 is 0. Negative 4 plus 4 is 0. So that's my new image. So let's go ahead. 1, 2, 3, 4, 5, comma 1. Here. Then I have 3, comma 3. 0, comma 3. And 0, 0. Okay, there's my image. So any questions so far on sequences of transformations? The most important thing with these is to write down each individual transformation, just like we've been doing, and keep track of the rules and keep track of the numbers. I'm telling you, this is the most time-consuming type of problem because you really have to write everything down. Notice how in this problem, I wrote everything down and then I noticed in the last second that I had it all wrong, right? So that's why it's super important to make sure that you're writing things carefully, because otherwise it can go wrong, just like it did for me. Okay, I had a couple more. I had a lot more, actually. Obviously, we're not getting to everything. So let me just see if I can think of a good one to go over. Okay, so here's one. So this is what it's going to look like more on a test. Can I have a volunteer read the question?
I can read it.
Go ahead, Tyrone.
Based on the graph below, which sequence of transformations is needed to carry A, B, C, D onto its image? A prime, B prime, C prime, and D prime.
All right. So we want to know, how do I go from, and I'm going to highlight them to make it easier, A, B, C, D to A prime, B prime, C prime, D prime. So look at your answer choices, start reading the answer choices to yourself, and for each answer choice, I want you to visualize what they're asking you to do and see if that makes any sense. And what I'm going to do for each of these is show you, what you could do is write the mathematical rules for each one, and that's going to give you a perfect answer. But if you're pressed for time like we are right now, it might be better to visualize things first so you can maybe have a guess, so predict which one might be right, and then use math to see if it's right. So I'm going to start with the first one. The first one is a 90-degree clockwise rotation about the origin, and then a reflection across the line y equals x. Okay, so I'm starting from the green one, right? If I have my green trapezoid and I reflect it 90 degrees about the origin, which quadrant will it end up in? 90 degrees clockwise. Quadrant 1, 2, 3, or 4? 4, right? So this guy would go 90 degrees. He would end up down here. So I'm gonna just sketch it. I would kind of visualize it in my head, and this is definitely not perfect, but just as a sketch, it would be something like this. Definitely a little bigger. I did not do a good job, but you get what I mean. We're just gonna sketch it. Something like that. Okay, and then it's saying you would take that and reflect it across y equals x. And which one is y equals x? What does y equals x look like?
Wouldn't it be like this?
Yeah, I see you, yeah. It's this diagonal line, right? Okay, so if I'm down here and I reflect over that line, is it gonna match? If I fold it in half over that line, are they gonna match?
If you take it from like the bottom one,
Mm-hmm.
and you flip it like that, yes.
But just the way it is, if I fold that in half, are they gonna match? I think Perla said no.
No.
Right, they're
No.
not. They almost do, but if you look carefully, they definitely will not. So I know A, just from visualizing, I haven't done any math yet, I know that's wrong. B, a reflection, let me erase my little drawings. Okay. B, a reflection across the x-axis and a translation by the rule, and then it gives you the rule. Okay. A reflection across the x-axis, which quadrant will it end up in? The green one. A reflection across the x-axis. If I reflect across the x, where will I end up?
Down on the bottom.
Underneath.
Quadrant
Good.
4.
Quadrant 4, precisely. So it's going to look something like this. Then if I take that and I translate it, 10 units to the left.
Wait, miss, is that 1.5 or is that 1 or is that 2 for the first point? For point A.
For point A, that's 3.
Yeah.
Oh, yeah, 2, 3.
Oh, okay.
But again, I'm not drawing anything that's perfect right now. I'm just visualizing. If I go and do that, if I go 10 units to the left and 9 units up, will it line up?
No,
No. Why not?
because it's facing the opposite way. You would have to flip it.
Perfect. Perfect answer. It's facing the opposite way. So, nope. All right. Going right along. A 180 clockwise rotation and then a reflection across the y-axis. Okay. If I go 180 degrees, where will I end up?
Quadrant 3.
Quadrant 3, precisely. Okay, so that's going to look, see, for this, I would definitely want to like visualize it first, but I think it's going to look like this way, something like that. Wait, no. There we go. Yeah, okay. Yeah, hold up. I'm turning my iPad, you guys, because that's what I need to do to check. Hold on. Yeah. Okay, see, I had it wrong. So it's actually like this. There we go. Okay, so if I do that and then a reflection, will it line up? Reflection across the x-axis?
I think it will.
You think it might? Let me draw a slightly better sketch of it so you can visualize it for sure.
If for a reflection, wouldn't it flip or something like that?
It would flip, yeah, across the, well, yeah, it would flip over the x-axis.
Actually,
Hold on, I keep drawing this wrong, you guys. I'm sorry. There we go.
Miss, you're confusing us.
I know.
I think it will. It's because like when we say reflection, it doesn't. It's not like really flip, I guess. Wait, I don't know how to explain it.
When I say reflection, I think of folding it in half. If I fold it in half across the red line, will it line up? Will green line up with blue?
Yes. Well,
Turn your head to the side. If you flip it, if you fold it in half, will it line up?
I don't think so.
When you say fold it in half, I get confused.
Girl, I don't know what to tell you. I'm saying all the words.
Can't fold it in half because the computer keeps auto rotating.
First world problems.
I don't think it will.
Okay. The right answer is no, it's not. It's not going to line up because it's facing the wrong way. The only way it would line up is if it looked like this. Look at it now. See, now if you fold it, that would actually fit. So C is wrong. D is what I think is right, but I'm going to double check by visualizing once more. Translation down 9 units. So if I move this down, it's going to be in the same orientation, right? So I'm actually just going to take this guy and move him. Let me see if I got it right. 9 units would put me 3 minutes at here. Okay. Oh, hello. What just happened? Whoa, that was weird. It just deleted everything I had. Okay. So yeah, if I take this and I move it down 9, now I'm here. And then I would have to do a 180. Where would I end up? What quadrant?
In quadrant 2.
In quadrant 2, which is the right place that I'm supposed to be in. So now I take a look and I just make sure if I went 180 degrees, would I end up in the same orientation as I'm supposed to be in? Flip your head around. Try and visualize.
I think so, yeah.
Yes.
Okay. Yeah. And you can always double check. How would I double check? If I had more time, what would I do to double check?
We would use our rule. So
Mm-hmm.
our rule is negative x and negative y.
Perfect.
And then the x becomes negative and the y becomes positive.
Exactly.
So it is.
All right. I know we went through a lot. We're going to do more. I did not have time for this. This one is my favorite activity. It's really fun. So I'm sad that we didn't have time for it, but maybe we'll have time tomorrow. I've said it once. I said it twice. I've said it now 50 times. What do you have to have memorized by tomorrow?
Our rules.
Gotta have those rules memorized. And I know some of you have been absent, so Eric and Samaj, you guys better be watching those videos on YouTube because I'm not going over it right now. It's your responsibility to go back and watch what you missed. Make sure you have them memorized by tomorrow. Have a good day. I'll see you then.
Bye.
Bye, Miss Lopez.
Bye.
Bye.